Hey guys, in this video we're going to be talking about solving systems of equations by graphing, and all of the problems we're going to be working with will have context, meaning that they are word problems. So let's get started. First one here says, Reagan and Sarah are having a competition to see who can do more push-ups. Reagan has already done 8 push-ups, and she can do 1 push-up per second. When Sarah joins her, she has done no push-ups, but can do 2 push-ups per second. All right, so first off, we have to write a system of equations that represents the situation. It says x is going to represent the number of seconds, and y is going to represent the number of push-ups. So in this problem, we see that Reagan has done a certain amount already, and we know what her rate of change is. And then similarly for Sarah, we know how many she starts with and what her rate of change is. So our equations are going to be in slope-intercept form. So for Reagan, we have y equals, she can do 1 push-up per second. So that's 1x, or just x, plus the 8 that she has already done. Sarah, on the other hand, can do 2 per second. So that's 2x, but she starts with none. So you can put plus 0 at the end, or you can just leave it. All right, now we're going to solve this system by graphing. And I have a graph here that we're going to use. So let me zoom out a bit. Will let me, which it won't. Okay. All right, so we have y equals 1x plus 8. So for Reagan, she starts at 8, which is right here, and she can do 1 push-up per second. Now, if you notice, our x-axis and our y-axis are changing by 2's. So I'm going to have to pay attention to that. So if she does 1 push-up every 1 second, that means Reagan can do 2 push-ups every 2 seconds. So I can just go up 1 over 1 each time since it's the same scale. And what I'm going to do is I'm going to get as many points as I can to represent Reagan's line. Okay, so now I'm going to draw my line, and this one right here represents Reagan. Now, Sarah starts at no push-ups, so she's going to start at the origin, and she can do 2 push-ups every 1 second, which means she can do 4 push-ups every 2 seconds. So I'm going to go up 2 and to the right 1. 2, 4 over 2, 2, 4 over 2, 2, 4 over 2, and there's my intersection point right there, which means my solution is 8, 16. So going back to the problem, for part B, the solution is 8, 16. And then for part C, it says, interpret the meaning of your solution in the context of the problem. Now remember, x is number of seconds and y is number of push-ups. And we were trying to figure, well, essentially we're trying to figure out here when they are the same. So that means that in 8 seconds, they both have done 16 push-ups. And that would be it for this problem. Let's try another. All right, it says, Rory and Seamus both have savings accounts. Rory has $45 in the account and deposits $10 each month. Seamus, on the other hand, has $25 in his account and deposits $15 each month. All right, write a system of equations that represents the situation. Let x represent the number of months and y represent the money in the account. So it's very similar here. So part A, we're going to write an equation for Rory and an equation for Seamus. We know how much Rory starts with and how it's changing, and we know what Seamus starts with and how his account is changing. So once again, this is y equals mx plus b. So for Rory, it's y equals, and she deposits 10 each month. Now deposit is a positive change, so it's going to be 10x plus what she starts with, which is 45. Now Seamus deposits 15 each month, so 15x plus the 25 that he started with. There's our 2 equations. Part B, solve the system of equations by graphing. All right, once again, I have a graph, but it's rather large, so the whole thing won't fit on the screen, but that's okay. All right, so for Rory, she started with $45 in her account. Now, if I'm looking at the scale, the x's are changing by 1s, the y's are changing by 5s. So 45 is going to be right here. And each month, Rory deposits $10, okay? So $10 is really only up 2 because it's counting by 5s. 5, 10, and over 1. 5, 10, over 1. And again, I'm going to get as many points as I can for this first line. And that would be it right there. So let's draw the line that represents Rory's account. And then let's talk about Seamus's line. Seamus starts with $25 and deposits $15 each month. So 25 is here. And $15 would be 3 lines, 5, 10, 15, and over 1. 1, 2, 3, 1, 2, 3, 1, 2, 3. There's the intersection right there. Draw Seamus's line. That means our solution is 485. So for part B, my solution is 485. And then part C says interpret the meaning of the solution in the context of the problem. So once again, slope-intercept form, when they meet is when they're the same. So for part C, it means in 4 months, they both have $45 in their account. And that would be it for that one. All right, so now let's move on and talk about how to do the same thing using Desmos. So first we're going to start with some procedural problems. That means problems that don't have any context. And we are going to use Desmos to solve the system, okay? So let me pull up Desmos. And I'll turn the screen here. So the first one we have is 2x plus 3y equals 10, and 4x plus 6y is 12. All right, so here is Desmos. Gotta refocus. Okay. All right, so I'm gonna type in the system that's on the paper here. So we have 2x plus 3y is 10, and I hit enter. And then I have 4x plus 6y is 12, okay? So now, 4x plus 6y equals 12, 2x plus 3y equals 10. So what I'm looking for here is the point of intersection. Now if I look, those lines look pretty parallel to me. So let's zoom out and make sure that that is in fact the case, which it looks to be. So remember, if something's going to be parallel, it means that their slopes are going to be the same. So if we take a look, if I had subtracted 2x this way, I would then divide by 3, which would give me a negative 2/3 slope. Similarly, if I subtract 4x and then divide by 6, I get negative 4 over 6, which is the same as negative 2/3. So it's true that this system is parallel, which therefore means there is no solution. So coming back to the paper here, let me refocus. This first problem here has no solution. All right, let's try another one. All right, so I'm going to go ahead and delete what we have here. And then our next one is 4x minus 6y is 12. And then we have negative 2x plus 3y equals negative 6. All right, if you look here, this one is one line right on top of the other. So that means that every single point on that graph is a solution. So if I'm coming back to my paper here, what I'm going to write for number 2 is infinitely many solutions. So IMS, or infinitely many solutions. Obviously, if not every single problem like that is going to be a special solution, well, all we're looking for here is the point of intersection. And we're going to see that in the following problems that we do with context. So let's try them out. All right. It says, a bookstore makes a profit of $2.25 on each book they sell and 75 cents on each magazine that they sell. 1 week, the bookstore sold X books and Y magazines for a profit of $450. The total number of items that they sold that week was 450. All right, so the first thing we need to do is write a system of equations that represents the situation, okay? So we have two things going on here. We have how much they make for each book and how much they make for each magazine, and we know how much money they made and what the total number of items was that they sold. So for this problem, we don't have a rate of change and a starting value for each thing that's going on here. So we're going to have two standard form equations. So I'm going to focus in on my two totals. One of the totals has to do with money and the other has to do with total number of items. So let's focus on money first because that's typically the easier of the two equations. All right, so we know that X is number of books, and each book they earn $2.25. So that's 225X plus Y is magazines, and they earn 75 cents for each one. So plus 75.75 Y, and we know they earned $450. So that's my first equation. The second one has everything to do with the number of items that they sold. Well, there's only two types of items. You have books and you have magazines. So when you add those two things together, so X plus Y, you get the $450. All right, so the next thing it wants us to do is to graph our system in Desmos, and then we're going to identify the solution. So let's flip on over to Desmos, and I'll refocus the camera. Okay, and let's delete what we have in here and put our new system in. So I have 2.25x plus 0.75y equals 450. Oopsies. 450. Okay. My second equation is x plus y equals 450. Okay. All right, now if you look at the screen, we see nothing. So we're going to have to zoom out until we find our system. And there is the intersection right here. Now the nice thing about Desmos is if you click right where, approximately where you think the intersection is, Desmos will put a point there for you, and then if you hover, you get the solution. So the solution for the system that we have here is 75,375. So I'm going to write that down, 75,375. So coming back to the paper, that was the solution that Desmos gave us. Now the last thing that it wants us to do is to interpret the meaning of the solution. Now remember, X was number of books and Y was number of magazines. So when I go to interpret, what I'm going to say is that they sold 75 books and 375 magazines. It's a little bit different than the last couple problems that we've done, simply because it's not when they're the same, it's the only point on the two lines, the two equations that we have here, where the number of books and the number of magazines is the same solution for both lines. So that's selling this many books and this many magazines is the only way they could sell 450 total items and also make $450. So that's what we're looking for here when we are interpreting what the solution is. And that's it. That's how you solve systems of equations by graphing in context.